14 point.
14.1. Betul dia lebih 1.
Okay. Molarity dapat tak? 1.781 mol per decimeter cube.
Saya tak dapat.
Awak assume apa? Tapi sepatutnya assume mana-mana pun akan dapat jawapan yang sama ke sebenarnya.
Saya assume dia punya mass 96 gram.
Okay, itu betul. Itu mass solution kan?
Mass. Saya assume mass H2SO4.
Solid ke solution?
Solid.
Tak boleh. Mass solid awak tak boleh assume. Awak boleh assume mass solution je.
Okay. Nanti saya buat balik.
Tapi, Tapi kalau awak assume mass, kalau awak assume mass H2SO4 96 gram, mass solution awak buat berapa? Awak buat 100 ke?
Saya mula-mula tu kan saya assume mass of H2SO4 96 gram. Lepas tu saya masukkan dalam formula ion density tu. Lepas tu saya dapat volume of solution.
Okay, dekat situ awak tersilap sikit. Sebab dalam density mass solution over volume solution, bukan mass solid over volume solution.
Macam mana saya?
Kalau density, density dia adalah mass solution over volume solution. Bukan mass solid over volume solution.
Okay.
Dekat situ. Awak assume tu dah betul lah. 96 gram tu dah betul lah. Cuma awak kena masukkan dalam formula percentage by mass instead of density.
Okay, faham.
Okay, boleh?
Alright, thank you sir.
Okay, welcome. Okay, so baru 59. Okay, tak apalah. Okay, kita start sekarang. Okay, Assalamualaikum. Ya, saya.
Boleh tanya soalan nombor 14.2 tak?
14.2 boleh? Okay. So question number 14 Roman 2, kita akan apply stoichiometry. Okay, stoichiometry ni actually saya tak ajar lagi. Tapi benda ni benda yang sama macam waktu sekolah menengah. Okay, so basically the question asks you to calculate the volume of H2SO4 solution. Okay, volume of H2SO4 solution given that the volume of H2. Okay, dia dah bagi volume of H2. Okay, tapi soalan cakap H2 tu dia measure at room condition. So remember that molar volume, so 1 mole of any gases is equivalent to 24 decimeter cube at room condition. Okay, tapi untuk question ni dia bagi the volume of hydrogen gas is 0.2015 decimeter cube. So awak buat mole constant, awak akan dapat mole H2. And then awak buat ratio lah. So tulis dulu balance equation. So kalau awak tengok balance equation, ratio between H2 and H2SO4 is 1:1. So that means they're going to have same number of mole. So awak dah dapat dah mole H2SO4, awak boleh cari volume H2SO4 dengan menggunakan molarity yang awak dapat dekat soalan 1 tu.
Faham.
Ni kejap lagi saya akan terang in detail lah stoichiometry ni. Saya akan terangkan in detail macam mana nak buat dia. Basically benda tu lah. Okay, boleh? Intan
Okay, boleh. Intan.
Okay.
Terima kasih, sir.
Okay. Sama. Okay. Yang lain ada soalan tak? Tutorial question yang lain? Tak ada? Okay. So kalau tak ada, okay, kita akan start dengan lesson 5 lah. So Assalamualaikum, very good morning everyone. Saya harap awak sihat sajalah. Okay. So for lesson 5, okay, we're going to learn about the chemical equation and also stoichiometry. So in chemical equation, we're going to learn how to balance chemical equation by using first one is inspection method, and the second one is by ion electron method or redox equation. Okay, so the learning outcome for today is the first one, you should be able to identify and explain redox reaction. You should be able to calculate the oxidation number of a given element, write and balance chemical equation by using inspection method and also ion electron. And the last one is perform calculation involving stoichiometry. Okay, so we're going to start with the first part of the lesson, which is redox reaction and oxidation number. Okay, so reaction, the most common redox reaction yang kita boleh nampak dekat sekeliling kita adalah rusting. That's the most common redox reaction yang berlaku lah. Rusting atau okay. So redox ni it come from the combination of term oxidation and reduction. Okay, dia daripada oxidation and reduction. Okay, and redox reaction it must occur simultaneously. Maknanya oxidation and reduction tu akan berlaku secara serentak. Okay, so example of redox reaction is combustion. Okay, combustion, rusting, okay, generation of electricity in batteries, itu kita panggil redox reaction. Basically, redox reaction ni, any reaction that involve the movement of electron, okay, any reaction that involve the movement of electron, kita akan panggil dia sebagai redox reaction. Okay, ada soalan setakat ni?
Tak ada, sir. Tak ada, sir.
Okay, so redox reaction ni awak okay lah. Okay, so normally in order to summarize redox reaction and on how you going to identify redox reaction, we're going to look at these 4 criteria. Okay, so for oxidation, if the number of oxygen increase, then the process we call it as oxidation. So if the reaction involve the removal of oxygen, then we call it as reduction. Okay, kalau hydrogen pula, hydrogen is the opposite of oxygen. If you remove hydrogen from a compound, that's what we call it as oxidation. If you add hydrogen in a compound, that's what we call it as a reduction. Okay, for electron, okay, if you donate electron, so this one, if you donate electron, so when you donate electron, the number of electron will be reduced. Okay, when you donate electron, we call it as oxidation. Reduction mean you gain electron. So that's why any oxidation process, the electron be located at the product side. Sebab kalau awak tulis chemical equation, kalau dia adalah oxidation, electron tu akan terletak dekat side product because oxidation involve donation of electron. So kalau kita donate, electron tu akan pergi daripada reactant ke product. That's why electron tu ada dekat product. So reduction is a gain of electron. That means electron tu ada dekat reactant. Okay, so when oxidation number increase, we call it oxidation. When the oxidation number reduce, we call it as reduction. So for example, Zn to become Zn2 plus. Okay, so zinc atom, the oxidation number is 0. We're going to learn this after this. Kita akan tahu macam mana nak determine berapa dia punya oxidation number dia. So for an ion, the oxidation number is +2. So if you look at the oxidation number, it increase from 0 to +2. That's why we call it this process as a oxidation. For reduction, so let's say I have 2Cl minus. Sorry. 2Cl2. Cl2. So if you want to produce Cl minus, you need to gain 2 electron. So this one from 0 to -2. So 0 to -2, the number dia akan menurun. That's why we call it as a reduction. Okay, boleh ni setakat ni?
Boleh, sir.
Boleh
Sir. Ada
Okay.
orang nak masuk.
Ada orang nak masuk?
Hmm.
Sekejap Tak ada pun.
Dia kata dia request tapi tak accept.
Tak ada pula kat sini. Selalu dia keluar. Suruh dia request balik boleh tak? Sebab tak keluar dekat saya punya komputer ni.
Baik sir.
Okay. Dia dah request balik ke?
Baru nak.
Okay. Sebab sekejap sebab tak ada pula dekat komputer saya. Dia dah masuk ke? Okay. Okay, so tadi macam saya cakap tadi, kita akan belajar macam mana kita nak determine oscillation number. So, the reason why we need to learn about oscillation number is awak akan apply ni waktu awak nak balance equation nanti. Awak nak balance equation redox nanti. Okay, there are few criteria ataupun few categories of oscillation number that you need to know lah. Okay, so the first one for a free element. Okay, free element that mean element yang dia tak bonded dengan apa-apa. So basically pure atoms lah. So pure atoms such as sodium atom, magnesium atom and aluminium atom. So for a free element, okay, the oxidation number must always equals to 0. So kalau saya ada sodium atom, oxidation number dia mesti 0. Hydrogen atom, oxidation number is 0. Chlorine atom, oxidation number is also 0. So free element that mean element that does not bond to any other element ataupun dia element dia sendirilah. Okay, that's what we call it free element. So for free element, the oscillation number is always equals to 0. It's always equal to 0. Okay, for a halogen, okay, halogen kita dah start ada exception, ada pengecualian. Okay, not all halogen have oxidation number of -1. Tapi -1 is the most common, tapi tak semua akan ada -1. Okay, so oxidation number for fluorine. Fluorine is always -1. Fluorine oxidation number dia takkan berubah untuk fluorine. Okay, for other halogen, they can have positive oxidation number when combined with oxygen or other halogen. So for example, kalau saya ada KClO3. If you look at this, the chlorine atom is bonded to 3 oxygen. It's bonded to 3 oxygen. So if you calculate the oxidation number of the chlorine atom, so the chlorine will have positive 5 oxidation number. So normally kita tahu kalau halogen negatif 1, tapi that's only applicable for fluorine. For other element in halogen group, when they bonded to oxygen especially or other halogen, they're going to have a positive oxidation number. Okay, boleh?
Boleh, sir.
Boleh ya? Okay. So the next one is hydrogen. Okay, the hydrogen, the most common oxidation number for hydrogen is -1. Okay, however, for a hydride is when the hydrogen is bonded to a metal. So when hydrogen is bonded to a metal, it's going to have oxidation number of -1. So for example, hydrogen when bonded with sodium, so it will produce sodium hydride. So the hydride will have oxidation number of -1. Okay, oxygen. Okay, for oxygen, the most common oxidation number is -2. Okay, kalau so contohnya macam the oxygen in CO2 for example. So the oxygen will have -2 oxidation number. However, when the oxygen is in peroxide, okay, is in peroxide. This is the general structure of peroxide. So the most common peroxide is H2O2, hydrogen peroxide. So H2O2 is commonly be written as HOOH. So when oxygen is in the form of peroxide, okay, it will have oxidation number of -1. Okay, that's the exception. Tapi the most common oxidation number for oxygen is -2. Okay, for a neutral molecule. Okay, for a neutral molecule, the sum of all oxidation number of all atoms is equals to 0. It's equal to 0. So for example, uh, NaCl. NaCl is a neutral molecule because it does not have any charge. Okay, so if I add the oxidation number of sodium and oxidation number of chlorine, I'm going to get 0. So for example, sodium, the oxidation number of sodium is +1. Chlorine in this case is -1. So +1 plus -1 is equal to 0. So neutral molecule, the sum of oxidation number must equal to 0. Okay, for a monoatomic ion. Okay, monoatomic, that means the ion only consists of one atom only. Only consists of one atom. So example of monoatomic ion is Cl minus, F minus, Br minus. So this is what we call as monoatomic ion. Okay, for a monoatomic ion, okay, the oxidation number is equal to the charge of the ion. So for F minus, oxidation number for F minus berapa?
-1.
Okay, correct. So it's equal to -1. Yes. So because it's equal to its charge. Okay, for a polyatomic ion, okay, polyatomic ion, the total oxidation number of all atoms that make up the ion is equal to the net charge of the ion. Okay, monoatomic, that means the ion only consists of one atom. For a polyatomic, the ion consists of more than 2 or more atoms lah. Example of polyatomic ion that we normally encounter, okay, in this course, so for example, kita ada nitrate ion or sulfate or dichromate or permanganate. So this is example of polyatomic ion lah. So for example, nitrate ion, the total oxidation number in nitrate ion is berapa? The total oxidation number.
-1.
Okay, correct. -1. For sulfate,
-2.
-2. You just take a look at the charge, the charge of the ion. Okay, so so example 1, okay, let's do it together. So determine the oxidation number of the underlying element. So the first one we have tin for fluoride. Okay, so in order to find the oxidation number of tin, so Sn, okay, so we need to plus with the oxidation number of fluorine. Okay, what is the oxidation number of fluorine?
-1.
Okay, correct, -1. Okay, and now we have 4 fluorine. So that means 4 multiply -1 is equal to
0.
0. Why 0?
It's a neutral compound.
Okay, neutral. Neutral molecule or neutral compound. Okay, so if you calculate, then the oxidation number of tin is equals to how much?
+4.
Okay, +4. Okay, oxidation number, even positive, you need to write down the sign. Okay, so positive or minus, you need to write down the sign. Okay, for dichromate, okay, we want to find the Cr. So Cr, we have 2 chromium. So that means 2 multiplied by Cr plus, okay, for oxygen, how much is the oxidation number for oxygen?
-2.
Okay, -2. However, we have 7 oxygen, then 7 multiplied by -2 equals to
-2.
okay, -2. Okay, if you calculate, what is the oxidation number of chromium?
6.
+6. Positive 6. Jangan 6 je tau. Kena +6. Because oxidation number, the sign is very important. Okay, okay, boleh tak? Okay, sekarang ni okay, boleh?
Boleh.
Boleh Okay, so kita okay, saya bagi contoh lah. Okay, so let's say kalau saya ada, okay, let's say kalau saya ada zinc plus HCl produce ZnCl2 plus hydrogen gas. Okay. So from zinc to ZnCl2, oxidation or reduction?
Oxidation.
Kenapa?
Oxidation.
Yes, correct. Oxidation. Kenapa?
Donate 2 electrons.
Okay, donate 2 electrons. So because this one, zinc, the oxidation number of zinc here is 0. This one is plus 2. So they donate 2 electron and the oxidation number increase from 0 to plus 2. That's why oxidation. So if one oxidation, so from hydrogen chloride to hydrogen gas is a reduction. And the oxidation and reduction process will occur simultaneously. Okay, so another example, kalau saya ada Fe2 plus Mn O4 minus produce Fe3 plus Mn2 plus. Okay, which one is the oxidation?
Iron 2.
So from iron 2 to iron 3. So this one is a oxidation. So because we look at the oxidation number will increase from positive 2 to positive 3. Okay. So from permanganate to manganese 2 is reduction. Okay. So berapa oxidation number manganese dalam permanganate ni? Kira dia berapa oxidation number dia?
Positive 9.
Positive 9.
Positive 7.
Positive
Positive 7. Positive 7.
7. Positive 7. This one is positive 2. So if you look at the oxidation number will reduce. Okay, the trick is normally we look at the transition element. Trick dia selalu kita tengok dekat transition element because transition element, one of the properties of transition element is they're going to have multiple oxidation number. So from there we can easily determine whether it undergo reduction or oxidation. Okay, so reason dia sebab nanti lepas ni kita akan belajar macam mana nak balance redox. Balance redox, the first step is you need to determine which one undergo oxidation and which one undergo reduction. That's why saya go through dulu benda ni. Even dia tak dalam syllabus tapi kita kena go through just because this is the basic one. Okay. Okay, so we proceed to the next part which is to balance chemical equation. Okay, by inspection method. Okay, inspection method maknanya basically awak look at the equation and then try and error. That's basically inspection method. Look at the chemical equation and then try and error. Okay, inspection method ni is the same macam yang awak belajar waktu sekolah menengah dulu. Okay, so for example kalau ada Ag silver nitrate react with calcium chloride to produce calcium nitrate and silver chloride. Okay, normally kita akan asingkan dia punya ni lah. So silver. Okay, nitrate. If you have a polyatomic ion, polyatomic ion and it does not change during the chemical reaction. So maknanya kalau dekat reactant dia NO3, dekat produk pun NO3. Itu maknanya does not change during chemical reaction. So kita akan groupkan dia sekali supaya dia memudahkan kerja awak. So this one nitrate, calcium, chlorine. Okay, this one how many silver? At the reactant part. Ada berapa silver?
1.
Okay, 1 silver. The product also have 1. So the nitrate at the reactor 1, nitrate in the product 2.
2.
Calcium 1, chlorine 2, chlorine 1. Okay, so if you look at apa kita dah analyse ni, so ada dua part lah yang kita kena balance kan. Kita kena balance nitrate and then kita kena balance chlorine. Okay, so this one nitrate is 2, this one nitrate is 1. So nak balance kan kita buat apa?
Multiply by 2.
Multiply by 2. Okay, boleh tak awak saya tambah 2 dekat sini? Boleh tak? Tak boleh kan? So kita hanya boleh tambah dekat depan. Okay, now the nitrate is already become 2, so the silver also become 2. Okay. So the silver become 2, so this one also need to become 2. And the chlorine is automatic become 2. So it's already balanced. Okay ni, boleh ni?
Okay.
Boleh sir.
Boleh.
Okay. Alright. So the second question, for a combustion of hydrocarbon, ataupun combustion of organic compound. Okay, this one we call it as a hydrocarbon lah ataupun organic compound. For combustion of organic compound, step dia, first one you need to balance carbon. Second one, balance hydrogen. Last kali baru awak balancekan oksigen. Kalau nak senang lah. Okay, so C2H4 plus O2 produce CO2 plus H2O. Okay, the first step you need to balance carbon. Okay, the reactant side we have 2 carbon. Product side we have 1. So kita akan tambah 2 kat sini. Okay, and then dah balance carbon, kita kena balance kita punya hydrogen. Okay, and the reactant side we have 4 hydrogen and the product side we have 2. So we need to add 2. So now the hydrogen is already balanced. Okay, the last one we need to balance oxygen. Okay, the product we have 2. 2 plus 4 is equal 6. So we only have 2. So nak balance kan macam mana? Multiply by berapa?
3.
Okay, multiply by 3. Okay, dah balance. Ini senang je. Okay, ini senang je. Okay. Okay, next part. Okay, kita nak balance redox pula. Okay, ni yang dia tak complicated pun, cuma dia panjang sikit. Dia panjang sikit. Okay. Sekejap, yang ni saya nak tanya, awak dah pernah belajar ke waktu sekolah menengah lu balance redox ni?
Pernah.
So sepatutnya dah tak susah sangat lah untuk awak. Okay. Okay, balance redox. Okay, bukan normally redox reaction, kita akan ada 2 condition. Either acidic or basic medium. Okay, the step to bring those 2 reaction is almost similar. Dia ada beberapa, ada satu step tambah lain je lah. Tapi yang lain dia sama. Okay, so we're going to learn about acidic medium first. Sebab acidic medium ni yang senang sikit. Okay, in order to balance redox reaction in acidic medium, kita ada 6 steps. Okay, the first one we need to divide. So we need to divide the equation into oxidation and reduction. Okay, sebab tu kita ajar awal-awal tadi macam mana nak determine which part yang undergo oxidation and which part yang undergo reduction. Okay, the second part or the second step is we need to balance atoms other than hydrogen and oxygen. Kita kena balance atom selain hydrogen and oxygen. Okay, and then we're going to balance oxygen. Okay, nak balance oxygen, we're going to add water on the deficient side. Maknanya kita akan tambah water dekat kawasan yang kurang oksigen. After balance oxygen, kita akan balance hydrogen. Nak balance hydrogen, kita akan tambah H plus at the deficient side. Okay, and then we balance charge. Okay, and then we combine. Okay, ni ada 6 steps ni. Okay, sebenarnya 6 steps ni awak boleh buat dalam 2 baris je. Tak perlu buat 6 line yang berbeza. Sebab kalau awak keep copy, takut ada benda yang tertinggal. So kita selalu kita buat dalam 2 line yang berbeza sahaja. Okay. So, kita buat sama-sama. Okay, so I have this redox reaction, MnO4 minus, okay, plus Fe2 plus, produce Mn2 plus Fe3 plus. Okay, this one we going, the reaction is happening in acidic medium. Okay, acidic medium. Okay, so the first step is we need to divide. We need to divide the equation into 2 half equation. Oxidation, reduction. Okay, so oxidation, okay, reduction. Okay, which one yang undergo oxidation?
Iron 2.
Iron 2 to iron 3. Okay, iron 2 to iron 3. So MnO4 minus to Mn2 plus will undergo reduction. Okay, the trick is kalau awak nak, nanti awak kena cancel out, awak kena tambah banyak benda. So cara nak memudahkan awak punya view tu, make sure the arrow from reactant to product tu selari. Make sure reactant tu selari. So tak adalah satu arrow kat sini, satu arrow kat sini. So awak boleh senang nak divide. Which one is the product, which one is the reactant. Okay, setakat ni ada apa-apa problem tak setakat ini? Semua okay?
Boleh
Okay,
sir,
so
okay.
Okay, so ni kita buat sama tau. Kita buat sama. Make sure awak ada kertas, ada pen semua. Okay, so we already divide the equation 2. The next step, we need to balance atom other than hydrogen and oxygen. Okay, so for the oscillation of equation, on the reactant part, we have one ion. So we also have one ion on the product side. So tak perlu balance sebab satu-satu. Okay, this one we have one manganese on the react side, and we have one manganese on the product side. So tak perlu balance. Okay, so dah balance item dah settle. Okay, the third part is we need to balance oxygen. Okay, nak balance oxygen, kita akan tambah water at the diffusion site. Okay, for the oxidation, perlu tak kita balance oxygen for oxidation?
tak perlu.
Tak perlu sebab dia tak ada oxygen. So awak boleh ignore. Okay, for the reduction part, on the reactant side, we have four oxygen. Produk kita tak ada oxygen. So kita perlu tambah berapa water?
4 water.
4 water at the product or reactant side?
Product.
Product side. 4 water. Okay, settle balance oxygen. Then we need to balance the hydrogen. Okay, for the oxidation, awak tak perlu balance apa-apa sebab dia tak ada hydrogen. Okay, tapi kita tengok reduction. Reduction, dekat produk kita ada 8 hydrogen. Dekat reactant, kita tak ada hydrogen. So, awak kena tambah apa?
8 hydrogen ion.
Okay, 8H plus. Right, so dah settle balance hydrogen, then we balance the charge. Okay, in order to balance the charge, okay, kita akan tambah elektron. Okay, so for oxidation, this one berapa charge total je?
Plus 2.
Okay, plus 2. This one, the total charge is plus 3. Okay, remember earlier in this lesson, kalau oxidation, elektron mesti dekat produk. Kalau reduction, elektron mesti dekat reactant. Itu cara awak nak check equation awak tu betul ke tak. Okay, in order to balance the charge, we need to add electron. We need to add electron to the more positive side. Okay, for the oscillation, okay, which side is the positive side? Reactant ke product?
Product.
Product. Okay, so we need to add how many electron to balance the charge?
1 electron.
Okay, correct. So we only need to add 1 electron. Okay, remember that 1 electron, the charge is equal to minus 1. So positive 3 plus minus 1 is equals to positive 2. So dah balance. Okay. So reduction part. So on the reactant, total charge berapa?
Positive 7.
Okay, correct. Positive 7. And this one, the total charge is positive 2.
Positive
So
2.
how many electron that we need to add?
5 electrons at the reactant part.
Okay, correct. So 5 electron. Okay. Okay, so sekarang ni, okay, before you combine the both equation, okay, we need to make sure that the number of electron on both equation are the same. So in the oscillation, we have 1 electron, we have 5 electron. Okay, apa yang kita kena buat?
Multiply by 5 to the oxidation equation.
Okay, correct. So multiply by 5. So Kalau saya multiply by 5, so your new equation is going to be plus Fe3 plus 5 electron. So this one Mn2 plus 4H2O, 5 electron plus 8H plus MnO4 minus. Okay, sekarang ni the number of electron is the same. Okay, sekarang ni awak akan dapat satu markah. Awak dapat satu je. Awak dah balance sampai electron baru awak dapat 2 markah. Satu untuk satu oscillation lah. Okay, so kita nak combine. Okay, kita kena ingat. If you have the same chemical species, okay, if you have the same chemical species and both are located on the same site, kita kena tambah. Kalau same species, different site, kita kena tolak. So for example, okay, dekat sini electron is dekat site reactant. This one electron dekat site product. So different site, same species, we need to tolak. So kita akan potong. So after you minus the electron, then you can combine. So combine dia jadi Fe2 plus MnO4 minus plus 8H plus produce plus Mn2 plus 4H2O. So this one is another mark for you. So normally this question will give you 3 marks lah. Okay. Ada soalan? Semua dapat buat tak? Dapat follow? Dapat
Saya nak tanya, tadi yang darab 5 kat atas tu kenapa sah?
Darab 5 sebab apa? Sebab kita nak samakan number of electron.
Sebab yang reduction tu yang 5 elektron tu, sebab tu kena darab 5 tu.
Ya, sebab reduction 5 elektron. So, dekat oscillation kita 1 je elektron. So, before awak combine equation tu, awak kena make sure number of electron sama. That's why kita darab 5.
Okay, saya terima kasih.
Boleh Okay, sama. Ada soalan yang lain? Okay, so kalau tak, kita proceed to basic medium. Okay, basic medium, sama je step 1 until 6 is the same. Tapi the difference is step 7. Okay, after you combine the equation, kita kena tambah hydroxide ion. Kita kena tambah hydroxide ion on both sides. Okay, and the number of hydroxide ion added depends on the number of hydrogen ion present in the chemical equation. Dia sama je 1 sampai 6, nombor 7 tu yang different. Okay, let's try this question. Okay, which one yang undergo oxidation? Siapa oxidation, siapa reduction? O3 tu reduction ke oxidation? Oxidation.
Yang mana?
Yang mana?
Yang CR tu reduction.
Kenapa awak cakap CR tu reduction?
H2.
Kalau kita buang H, oxidation ke reduction?
Oxidation.
Kita buang H adalah oxidation. And kalau kita tambah H adalah reduction. So kalau awak tengok, the chromium, chromium 3 hydroxide, become ion. So kita dah remove hydrogen. So remove hydrogen, that means oxidation. So oxidation is CrOH3 CrO3 2 minus. And then if you calculate the oxidation number for chromium, chromium dekat reactant is plus 3 and chromium the product is plus 4. Kalau awak kira dia punya oxidation number. So oxidation number dia increase lah. Okay, and then reduction is O3 minus produce I minus. One is a reduction because we remove oxygen. Okay, so once you already divide, then we need to balance the atoms. Okay, ada perlu tak kita balance itu? Ada tak yang mana-mana equation perlu balance atoms? Dekat oxidation ada berapa kromium dekat reactant?
Satu.
Satu. Dekat produk pun satu. So, tak perlu apa-apa. Dekat reduction, iodine ada satu. Produk pun ada satu. So tak perlu balance. Okay. So balance atom settle lah. Okay. And then we balance oxygen. Okay. On the oxidation. Okay. Dekat reactant ada berapa oxygen?
3.
3. Dekat produk? 3. So perlu balance tak?
Tak perlu.
Tak perlu. Okay. So reduction. Reactant ada 3, produk tak ada. So we need to add how many water?
3 water.
3 molecule of water. So balance oxygen and then we balance the hydrogen. Okay. Oxidation tu perlu tak balance oxidation? Perlu tak?
Perlu.
Perlu. Tambah berapa hydrogen ion?
3.
Okay, tambah 3. Okay, dekat reduction perlu tak?
Perlu.
Kita tambah
6.
6.
6. Okay, correct. So, and then we balance the charge. Okay, this one, the charge is 0. This one, the total charge is -2 plus 3 is positive 1. Positive 1. So, how many electron that we need to add?
1 electron.
Okay, 1 electron at the product or reactant side? Okay, at the product. Okay, so for the reduction, so -1 plus 6 is plus 5. It's -1. Okay, how many electron that we need to add? 6 electron. Okay, correct. So 6 electron at the reactant side. Okay, so now before you combine, we need to make sure that the number of the electron is the same. Okay, reduction kita ada 6 electron, oxidation we only have 1. So what we need to do is we need to multiply the whole oxidation with 6. Kita kena multiply. Jadikan 6, so kita akan dapat 6CrOH3. Okay, produce 6CrO3 minus plus 18H plus 6 electron. Okay, so IO3 minus plus 6H plus 6 electron. So we don't know minus plus 3 H2O. Okay, so boleh combine tak?
Boleh, sir.
Boleh, okay. So ingat before you combine, kita kena cancel out ataupun kita kena tambah apa yang boleh tambah. So we have 6 electron on the reactant side and we have 6 electron on the product side. So we can simply cancel out dia. Okay, ada lagi tak yang boleh cancel out selain electron? Hydrogen, okay, betul. Okay, kalau awak tengok dekat sini ada 18H plus at the product and we have 6H plus at the reactant. So 18 minus 6 is 12. So this one become 12H plus. So the new, so sekarang ni boleh combine lah. Sekarang boleh combine. So kita akan dapat 6CrOH3 plus IO3 minus produce 6CrO3 minus plus I minus plus 3H2O plus 12H plus. Okay. Tapi kalau dia minta sampai acidic medium, awak kena stop sini. Tapi sebab dia nak basic medium, after you combine, we need to add OH minus. Okay, the number of OH minus you add depends on the number of hydrogen ion. Okay, so if you look at this question, we have 12 hydrogen ion. So you need to add 12 OH minus on both sides. So kena tambah 12 OH minus on both sides. So this one add 12 OH minus. This one you need to add 12 OH minus. Okay, setakat ni okay. Boleh?
Boleh sir.
Okay. So, kita akan ada new equation. So, kita akan ada new equation. Okay, sekarang ni. Awak tengok. 12 OH plus. Kalau dia bertindak balas dengan 12 OH minus, dia akan form water. So, dia akan form berapa molekul water? Berapa molekul?
12.
12 molecule of water. Okay, so it produce 12 water. Okay, and then we have 12 water and 3 water molecule on the same side. So kalau ada same thing at the same side, we need to add. So total water yang kita akan form adalah berapa?
15.
Okay, 15 water. Okay, so your new equation is going to be 6Cr OH3 plus IO3 minus plus 12 OH minus CrO32 minus plus I minus plus 15H2O. So this is your final answer. Okay, for a basic medium, normally the mark is 4 marks. So 1 mark here, then you combine, and then your final answer is 1 mark. Okay, okay boleh ni?
Boleh sir.
Okay, so saya bagi masa awak 10 minutes. Try kedua-dua ni. And then nanti macam biasa upload answer kat Padlet saya akan bagi link Padlet yang baru. Okay, 10 minutes. Okay, boleh mula. Kalau ada apa-apa soalan tanya je. Okay, saya dah bagi link Padlet tu. Awak boleh try 10 minutes saya bagi. Sekejap, tadi yang nak masuk tu dapat masuk tak?
Dah.
Dah, okay, okay. Sementara buat ni, kalau siapa-siapa macam yang nak left dulu ke, boleh je. Nanti lepas ni kita masuk balik. Lepas awak upload tu, awak masuk balik join Google Meet kalau siapa-siapa yang nak left.
So,
Ya, saya.
untuk yang question nombor tu, yang basic medium tu, oxidation dia MnO4 tu kan?
Bukan, cik, kalau yang MnO4 tu, kalau awak kira oxidation number, cik kira oxidation number manganese dekat reaktor, tengok oxidation number manganese product. Dia menurun ke tak?
Menurut
Menurun. Kalau menurun, dia adalah
reduction.
reduction.
Alright, thank you sir.
Sama. Okay, dah dapat lah. Dah siap lah semua.
Yang soalan 2 belum lagi sir.
Okay. Soalan 2 tu dia bukanlah panjang sikit je. Yang nombor 1 tu dapat lah, nombor 1.
Dapat sir.
Nombor 1 senang kan? Nombor 2 tu yang ni sikit. Apa, cuba buat.
Sir,
Ya saya.
contoh kalau dia punya elemen tu 2 Cl minus kan. Dia punya
Okay.
charge jadi minus 2 ke minus 1 je?
Total dia kali minus tu lah, sebab awak ada 2 Cl minus. 1 Cl minus ni kecil 1. Sekali awak ada 2, so jadi 2. 2 lah.
Alright, thank you sir.
Sama. Okay, saya tulis jawapan untuk yang Roman 1. Awak check bersama tak dengan jawapan awak. Saya bagi masa lagi 5 minit sampai 10-20 sebab kita stoichiometry tak masuk gini. Stoichiometry ni. Okay. Tu yang mana? Betul. Okay, so diorang dah hantar dekat pada. Okay, jawapan awak ni daripada Chiang H65 and then lagi seorang ni tak ada nama dah pula. Dua-dua betul. Aziz. Okay, betul. Jangan lupa submit yang basic medium sekali. Yo Joan. Okay. Alright, correct. Haziq. Haziq? Oh, Haziq Zakwan.
Saya lupa cancel out H2O tu sir.
Okay, sebelum combine cancel out mana yang boleh? Okay, lagi 3 minit. Sebab kita nak masuk stoichiometry lepas ni. Kalau tak sempat submit dalam kelas ni, awak submit lepas ni lah. Lepas kelas ni awak submit. At least semua dah siap lah. Roman 1 dah siap. Yang acidic medium dah siap. Okay, tak apa. Awak, siapa yang dah siap Roman 1 tu, yang basic medium tu nanti awak siapkan nanti awak submit kat saya. So, kita masuk stoichiometry. Sekarang boleh? Kita masuk stoichiometry.
Boleh sir.
Boleh ha? Okay. So, yang lain tu nanti submit lepas ni lah. At least awak dah siapkan satu. Okay, semua dah ready belum ni nak sambung ni? Stoichiometry.
Ready sir.
Okay. Okay, stoichiometry. Okay, stoichiometry ini macam saya cakap waktu kita punya first lesson dulu, calculation dalam chemistry ni tak susah pun. Dia semua ratio je. So, kalau awak mahir macam mana nak apply ratio dalam calculation, memang senang lah nanti calculation dalam chemistry. Boleh dengar suara saya?
Sekarang boleh
Boleh sir.
Boleh dengar tak suara saya?
Boleh sir. Boleh sir.
Sorry tadi saya punya laptop dia restart. Tak tahu kenapa. Sabar, saya boleh dengar yang sekarang kan?
Boleh.
Boleh Okay, saya proceed sekarang lah sebab tadi. Okay, so stoichiometry. Okay, stoichiometry is basically the quantitative. Okay, so it's a quantitative relationship of molar ratio that we can use. Okay, okay, so quantitative relationship that we can use to determine the molar ratio of any substance lah, dengan syarat equation tu mesti balance chemical equation. Okay, so mesti the balance chemical equation. So for example, if we consider the equation, C3H8 plus 5O2 produce 3CO2 and 4H2O. Okay, so from this balance equation, the information that we can obtain is 1 mole of C3H8 dia akan react dengan 5 mole of O2. Dia akan react dengan 5 mole of O2. Okay, so 1 mole of C3H8 dia akan produce 3 mole of CO2. Okay, boleh ni? Boleh dapat tak?
Boleh,
Boleh, sir.
sir.
Boleh sir.
Okay. Okay. So, itu maknanya stoichiometry. Maknanya relationship between atom dalam balance ataupun relationship between compound dalam chemical equation tu. Ini maknanya stoichiometry. So, normally stoichiometry, okay, stoichiometry juga kita boleh represent dia yang guna garis 3 tu. So, maknanya 1 mole of C3H8 is equivalent to 5 mole O2. Equivalent to 3 mole CO2 and equivalent to 4 mole H2O. Mana saya dapat nombor 4, 3, 5, 1 tu saya dapat pada mana?
Equation.
Okay, daripada balance equation. So that's why normally the first step, in order to solve stoichiometry problem is you need to have a balanced chemical equation. Itu first step kita. So kalau balance equation awak salah, awak punya stoichiometry, awak punya ratio pun akan salah. So at the end awak punya jawapan pun akan salah lah. That's why awak kena make sure equation yang diberi tu dah betul-betul balance. Okay. In order to solve a stoichiometric equation, okay, first we need a balanced chemical equation. Okay, we need a balanced chemical equation. Okay, and after that, normally in a stoichiometry problem, we need to convert anything that we have into number of mole. So, once kita dapat the number of mole of one substance, by using stoichiometry, kita boleh cari number of mole of another substance. Okay, boleh?
Boleh, sir.
Boleh, sir.
Boleh So apa-apa cari number of mole daripada balance equation, cari number of mole untuk satu substance, and from there we can find the number of mole of another substance. So dia senang je. So cuma awak kena apply macam mana nak cari molar mass, nak cari volume, nak cari number of mole, from number of particle, semua tu apa yang kita belajar last week. So awak kena apply balik dalam soalan stoichiometry. Okay, so let's take a look at this example together. Okay, so in an experiment, 2.5 gram of zinc is allowed to react with excess hydrochloric acid solution to produce zinc chloride and hydrogen gas. Okay, so the first part is write a balanced chemical equation. So zinc react with HCl, produce zinc chloride. Okay, what is the chemical formula for zinc chloride?
ZnCl2.
Okay, ZnCl2. Okay, plus hydrogen gas. Okay, dah balance belum?
Belum.
Belum. So, what we going to do in order to balance? Kita tambah apa?
2 dekat HCl.
Okay, we add 2 at the HCl. Okay, so now dia dah balance. Dia dah balance lah. Okay, so question B. Determine the number of mole of HCl required for the reaction. Okay, we need to find the mole of HCl. Tapi from the question, dia bagi tak apa-apa information dekat HCl?
Tak ada.
Tak bagi.
Tak ada.
Tapi given in the question is the mass of zinc, which is 2.5 gram. Okay, remember that from mass nak convert to number of mole, kita buat apa?
Divide by molar mass.
Okay, divide by molar mass. Okay, so we find the number of mole of zinc, which is 2.5 gram, divided by molar mass is 65.4 gram per mole. Okay, the number of mole of zinc is 0.0382 mole. Okay, now, macam cakap tadi, kelas stoichiometry problem, once awak dah tahu number of mole of one substance, you can use a ratio to find the number of mole of another substance. Okay, now the question asks you to find the number of mole of HCl. Okay, so kita buat stoichiometry. So based on the balance equation, okay, what is the ratio between zinc and HCl? Ratio dia
1
berapa?
to 2.
Okay, 1 to 2. Okay, so 1 mole zinc is equivalent to 2 mole of HCl. So 1 mole of zinc, so now we have 0.0382 mole zinc. So how many mole of HCl?
0.00764.
Okay, mole HCl. Okay, you just multiply by 2 lah. So the number of mole of HCl is equal to 0.0764 mole. Okay, so settle. Okay, C, determine the volume of hydrogen gas. Okay, the volume of hydrogen gas at the standard temperature and pressure. Okay, in order to find the volume, you need to have the number of mole of H2. So macam mana nak cari number of mole of H2? Kita buat apa?
More ratio.
Kita buat ratio kan. So from zinc, kita compare pula zinc dengan H2. So 1 mole zinc is equivalent to 1 mole H2. So given that the number of mole of zinc is 0.0382 mole zinc, so since the ratio is 1 to 1, so H2 also going to have the same number of mole as zinc. Okay, H2. Okay, now we have the number of H2, we can find the volume. Okay, the volume of H2 at standard temperature and pressure. So 0.0382 mole multiplied by what? What number?
22.4.
Okay, correct. 22.4 sebab STP. 22.4 liter per mole. So we can cancel out. So your final answer is going to be 0.85568 liter. Okay, boleh ni? Stoichiometry ni.
Boleh, sir.
Yeah. Senang je. Very senang. Dia cuma awak kena ingat. In order to solve stoichiometry, first you need to have a balanced chemical equation. The second one is you need to find the number of mole of one substance. From there, you can apply stoichiometry to get the number of mole of another substance. Okay. So, kita tengok yang ni. A 25 mil of potassium oxalate, okay, is titrate with 50 mil of 0.25 molar potassium permanganate. Okay, calculate the concentration of C2O4 2- solution used in the titration. Okay, so from this equation, okay, from the question given that the potassium oxalate, okay, volume is 25 ml. Okay, for permanganate, given that molarity is equal to 0.25 molar, volume is 50 ml. Okay, the question asks you to find the concentration of C2O4 2-. Okay, apa nak buat dulu? So kita nak buat apa? Any suggestion? What's the first step?
Find mole of the MnO4.
Okay, find the mole of NM04. Okay, so we have molarity and we have volume. So now kita boleh find the number of mole. Okay, we have molarity and volume, we can find the number of mole. So mole of MnO4 minus is equal to molarity multiplied by volume divided by 1000, since the volume is ml lah, because we need to convert ml to liter. So what is the number of mole of permanganate?
0.0125.
0.012
25.
125 mole. Okay, so once you obtain the number of mole permanganate, then we can find the number of mole for oxalate. So we use stoichiometry. So based on the balance equation, so 2 mole MnO4 minus is equivalent to 5 mole of C2O4 2-. Okay, given that the mole is 0.0125 mole per manganate, okay, how many mole of oxalate?
0.03125.
Okay, mole of oxalate ion. Okay, now we obtain the number of mole. Can we find the concentration? Boleh tak kita cari concentration dia? Kita buat apa nak cari concentration? Molarity of oxalate. Kita buat apa? Apa bahagi apa?
Mol bagi volume.
Okay, mole bahagi
Volume.
volume. So volume of oxalate is 25 mil. So you divide by 1000, then you will get 0.025 liter. So your final answer is berapa final answer awak?
1.25
1.25.
mol per liter.
Mol per liter ataupun mol lah. Okay, senang je. Stoichiometry tak susah pun. Dah, itu je sebenarnya. Awak dapat satu, awak boleh cari yang lain. Okay, boleh ni?
Boleh, sir.
Boleh. Okay. So, okay, that's all for today. So, you can try tutorial question number 15 until 22. Okay, and for the next lesson, which is on Wednesday. On Wednesday, I think. Kita Wednesday. So, we're going to learn about limiting reactant and percentage yield. Okay. So, kalau tak ada apa-apa, so kita stop sekarang lah. Okay, thank you everyone.
Thank you, sir.
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 Sama.
Thank you, sir.
Sama.
sir.
Welcome.
Thank you, sir.
Sama.
Kan esok kan ada awan haram kan?
Apa sih? Waram.
So dia buat clear medical besok.
Aziz, awak telegram saya lah.
Apa dia sir?
Okay, awal Muharram. Awal Muharram.
Esok saya nak buat kelas ke sir yang practical?
Macam ni, esok pre-lab je. Kan selalu pre-lab saya suruh hantar hari yang sama kan? Yang ni saya suruh hantar hari Rabu lah, Rabu malam. Saya bagi je macam biasa, tapi awak submit lambat sikit lah.
Okay sir. Okay.
Okay.
Okay sir. Terima kasih sir. Selamat cuti sir.
Selamat cuti.